Yes! I'm so excited to welcome you to this revision video. In this video, we will explore essential chemistry concepts, ensuring a clear and concise understanding in preparation for the SS2 second term chemistry examination in SFC. It can also be useful to non-SFC students. Let's begin. 1. Atomic structure and periodicity. Do you know your atoms? An atom is the smallest unit of an element that retains its chemical properties. It consists of protons, neutrons, and electrons, with protons and neutrons forming the nucleus while electrons move around in energy levels. Make sure you can draw the atomic model. Try lithium, sodium, magnesium, chlorine atoms, including sulfide, oxide ions electron configurations. What about the modern periodic law? The periodic law states that the properties of elements are a periodic function of their atomic numbers. This means elements in the same group have similar chemical behaviors due to their valence electrons. Noble gases, such as helium and neon, are unreactive because they possess full outer electron shells, making them chemically stable. Do you know oxides? We have metallic oxides and non-metallic oxides. In metallic oxides, we have basic oxides, which are capable of neutralizing an acid. The oxides include something like sodium oxide, potassium oxide, barium oxide, and calcium oxide. We also have amphoteric oxides from the metallic oxides, which react with both acids and bases. It includes zinc oxide and aluminium oxide, lead-2 oxide. We have non-metallic oxides divided into acidic oxides, or better called acid anhydrides. They include all oxides of the halogens, sulfur 4 oxide, SO2, sulfur 6 oxide, SO3, nitrogen 4 oxide, NO2, nitrogen 5 oxide, N2O5. They all dissolve in water to form acids. This is the reason they are called acid anhydrides, meaning acid with no water. We have only 4 neutral oxides as water, nitrogen 1 and nitrogen 2 oxides, carbon 2 oxide. 2. Chemical nomenclature and oxidation states. Iron 3 oxide, represented as Fe2O3, follows IUPAC naming conventions. Note that the 3 means the oxidation state of iron in the compound. While NH for NO3 is ammonium trioxonitrate 5, the 5 is the oxidation state of nitrogen in the NO3 ions. KMNO4 is potassium tetraoxomanganate 7, the 7 is the oxidation state of manganese. Oxidation state is the atomic charge of an element in a compound. The oxidation number of chromium in potassium dichromate, K2Cr2O7, can be determined using algebraic sum rules, yielding +6 for chromium. Potassium, K is +1, oxygen is -2. So we look for chromium and get it as +6. Can you do it? Try KCrO4. In the reaction between zinc and copper, 2-tetraoxosulfate 6. Zinc acts as the reducing agent, donating electrons, while copper, 2 ions serve as the oxidizing agent, accepting electrons. You can try finding the oxidizing and reducing agent in chemical equations. 3. Separation techniques and solutions. In this examination, we will be looking into crystallization, evaporation, distillation, chromatography, and fractional distillation. You have to know their principles. Their techniques. For instance, chromatography operates on the principle of differential adsorption, where components of a mixture move at varying speeds on a medium. This technique is widely used in forensic science for identifying substances in mixtures. Fractional distillation is employed in crude oil fraction separation due to differences in boiling points of its components, allowing them to condense at distinct temperatures. 4. Water and solubility. Do you know about soft and hard water? How can you soften temporary and permanent hard water? What about solubility? Solubility refers to the amount of solute that dissolves in a given solvent at a specific temperature, influenced by factors such as temperature and pressure. To prepare a 1 moles per decimeter cube solution of sodium chloride in 500 centimeters cube of water, the required mass can be calculated using the formula mass equals molarity times molar mass times volume in dm cube, yielding 29.25 gram of NaCl. To obtain a saturated sodium chloride solution, dissolve salt in water until no more dissolves, then filter out undissolved residues. 5. Chemical equilibrium. Do you know Le Chatelier's principle in chemical equilibrium? What about how to balance the redox reaction equation of acidified permanganate and iron 2+? Note that the permanganate ion acts as the oxidizing agent, while iron 2+ serves as the reducing agent. Some gas laws to consider. Boyle's law states that at constant temperature, the pressure and volume of a gas are inversely proportional. Charles' law asserts that at constant pressure, gas volume increases with temperature. An example can be if a gas at 30 cubic centimeters and 27 degrees Celsius is heated to 57 degrees Celsius. The new volume is found using V1, T1 equals V2, T2. 30 times 330 over 300 by calculation gives 33 centimeters cube. Graham's law states that the rate of diffusion of a gas is inversely proportional to the square root of its molar mass, explaining why lighter gases diffuse faster than heavier ones. Heavier gases diffuse slower. For instance, hydrogen chloride gas of molar mass 36.5 grams per mole diffuses slower than ammonia gas 17 grams per mole. 6. Kinetic theory and states of matter. The kinetic theory of gases assumes that particles are in constant motion and collisions of gaseous particles are elastic. Increasing temperature raises kinetic energy of the particles of any substance, leading to faster molecular movement, causing more randomness, colliding with one another and with the wall of their container. The move away. The spreading of molecule is diffusion. Diffusion involves particle movement from higher to lower concentration, whereas osmosis is the diffusion of water across a semipermeable membrane. The two are phenomena used in proving the kinetic theory of matter. Other include Brownian motion. 7. Carbon and its compounds. Carbon has two distinct crystalline allotropes which are diamond and graphite. Diamonds are extremely hard with a high melting point, while graphite is a good conductor of electricity due to free electrons. You can look into more properties of the allotropes. Carbon monoxide is poisonous as it binds to hemoglobin, preventing oxygen transport. It can lead to death. When carbon dioxide reacts with lime water, an insoluble white precipitate of calcium carbonate forms. This is the test for the presence of carbon dioxide. 8. Oxygen, hydrogen, and their reactions. Oxygen is prepared in the laboratory by decomposing hydrogen peroxide or heating potassium trioxochlorate 5. Learn the balanced chemical equations for preparation of elements and gases. Don't forget the diagram for the preparation of oxygen and hydrogen. Oxygen supports combustion by reacting with fuels to release energy, forming oxides. Hydrogen gas can be prepared in the lab by reacting zinc with dilute hydrochloric acid, as shown in the reaction. Calcium hydride also reacts with water to produce hydrogen. 9. Electrolysis and thermochemistry. Electrolysis involves the breakdown of a compound using electricity. Copper, 2-tetraoxosulfate 6 solution conducts electricity due to the presence of free ions, unlike sugar solution, which lacks mobile charge carriers. During the electrolysis of concentrated NaCl, that is brine. At the cathode, hydrogen gas is liberated. At the anode, chlorine gas is liberated. As the reaction goes on, the electrolyte solution will change to sodium hydroxide, which is alkaline in nature. It will turn a litmus blue. The heat of reaction to look into include heat of combustion, formation, vaporization, and neutralization. Heat of neutralization refers to the enthalpy change when hydrogen ions form an acid and a hydroxide ion from a base reacts completely to form water. Exothermic reactions release heat, such as combustion and neutralization reactions, while endothermic reactions absorb heat, like photosynthesis. Thermal decomposition reactions. The enthalpy change of an exothermic reaction is negative because energy is lost to the surroundings. 10. Sulfur compounds and ammonia. The contact process produces tetraoxosulfate 6 acid and sulfur 6 oxide. Vanadium 5 oxide acts as a catalyst, speeding up the oxidation of SO2 to SO3. Do you know its uses? Tetraoxosulfate 6 acid is used in fertilizer production and car batteries. It can be prepared in the lab by reacting to sulfur for oxide with oxygen and water. Ammonia is prepared by heating ammonium salt with an alkali. It is used in fertilizers and cleaning agents. 11. Chlorine and properties. Chlorine gas has a pungent smell and a greenish-yellow color. It is prepared in the lab by reacting concentrated hydrochloric acid with manganese for oxide. The diagram is important. Hydrogen chloride is acidic in water but not in tetrachloromethane. You may be asked why? Hydrogen chloride dissolves in water to form hydrochloric acid, which ionizes and turns litmus red. However, in carbon tetrachloride or tetrachloromethane, it remains a neutral gas, as no ionization occurs. 12. Mole concept and gas calculations. A mole is the amount of a substance containing Avogadro's number of particles. To determine the number of moles in 8.8 gram of carbon for oxide, use moles equals mass over molar mass. By substitution, 8.8 G divided by 44 grams per mole equals 0.2 mole. Look into stoichiometry involving the production of nitrogen from ammonium dioxonitrate 3. This concludes our revision session. Keep practicing these concepts to strengthen your understanding. Best of luck in your exams.